First equation that allows us to describe light as a wave is F equals 1 over t, and t equals 1 over f. F is frequency, and t is period. In other words, frequency and period are inverses of each other. Period is the amount of time it takes for a wave to repeat itself, the amount of time it takes for a wave to complete a single cycle. It's the peak-to-peak distance on the graph. Let's say that this single time repetition is 5 seconds. What frequency corresponds to this? Frequency shows up a lot in chemistry problems, but using a graph to find it is unnecessarily complicated. Instead, let's use this equation. And it may be helpful for your understanding to specify that period is a time frame per cycle of the wave, because that's what it is. It's an amount of time that it takes for a wave to complete a single cycle. We plug it in to get our frequency. See how we just put it in and then take the inverse? And then we get 1 cycle per every 5 seconds. We often remove the cycle term at the end, so it's just 0.2 seconds inverse. Next up, we have something simple yet overlooked and useful, and that's that 1/4 of a wave cycle is the same as a nodal separation. A wave has recurring nodal points, which are simply every time the vertical displacement is at a maximum, a minimum, or 0. Adding in the graphical definition of a cycle, we can see that it starts and ends at a node. Every cycle is the same horizontal distance as 4 nodal separations, i.e. the horizontal distance between 4 consecutive nodes, from here to here, plus here to here, plus here to here, all the way to here. Conversely, 1 nodal separation is 1/4 of a cycle. Thus, as with our frequency-period relationship, we have 2 opposite equations communicating the same information. Perhaps the most important light wave equation of all is C equals lambda times f. Lambda is wavelength, f is frequency, and c is propagation speed. Propagation speed is the speed at which a light wave travels forward. This is also known as the speed of light, and it's 2.998 times 10 to the 8 meters per second. Which by definition then is the product of these 2 terms. Thus, this means that all 4 of these green statements are true and thus interchangeable, meaning that the product of these 2 terms is equal to all of these things. Likewise, since propagation speed is a speed term, it's going to use units of distance divided by time. In other words, we're going to use meters per second to follow SI units. And we account for this by wavelength having meters, a type of a distance, and frequency having seconds inverse. So when we multiply these 2 together, it just goes on to the denominator. Let's bring in equation 1 to really marry everything together. Substitute frequency with what it's equal to, 1 over t, and we derive c is equal to lambda over t. And we can see that the units work out, and in fact, they're way more intuitive from a conceptual standpoint. If speed equals the change in distance over change in time, here's our change in distance, and here's our change in time.